In this video, we will learn about moments about an axis, topic 4.4, 4.5. Moment about an axis. In the previous video, we talked about moment about a point, and this time we are talking about moment about an axis or a line. And we use both scalar analysis and vector analysis for this. When determining the moment of a force about a specified axis, the axis must be along. It can be any line in three-dimensional space. Triple scalar product. This mathematical expression is called triple scalar product, where this period here is actually dot product. It's not multiplication, and this is cross product. So this equation states that it is the cross product of R cross F and the dot product between U and that cross product. It's always a scalar quantity which is positive or negative, because dot product is always a scalar quantity. So let's look at this example. When the force P is applied by a person, that force results in rotation about A or moment about A for the socket range. Does all of the moment of A act to turn the socket? How would you calculate the answer to this question? So when force S is applied, it results in moment about A, but not all of that is responsible for turning the socket, because there is an angle between the socket and the A. So socket or this has tendency to rotate about A, and this is called an axis. So we need to apply the concept of moment about an axis to calculate the moment of P about this axis. And for that, we can use triple scalar product. So we need P as a Cartesian vector. Then the second thing is we need a position vector. Position vector can have tail anywhere along the axis of rotation, and the head of the position vector can be anywhere along the line of action of the force. So let's call this R, and let's call this P, like F or P, the force that is applied, and this is axis has direction UA, which indicates the unit vector along axis A. Then we can calculate how much of this moment actually is responsible for turning the socket about vertical axis, and that can be calculated using UA dot product R cross F. And this is always a scalar quantity. That means we will get either some positive or negative number depending on the direction of rotation. Another application, this force F is applied on the bracket, which results in rotation about x axis. How can we calculate the moment of F about x axis? So we again apply the same thing. We find out the direction for x axis, which is ux or unit vector is for x axis it's I. So unit vector in that direction is I. Then we have a force vector, and then third thing we need is position vector, which should have tail anywhere along x axis and head anywhere on the force line of action. So this is R. So again it's I dot R cross F gives us the moment of this force about x axis. So this is where we are. So yeah, so this is generalized explanation of moment about an axis. So moment about an axis A, in this case this is the axis A. This is where the force is applied, and this is the position vector, and it can be calculated using U dot R cross F, where the second and third rows, they are same as before, three components of R, three components of F, but the first row are three components of unit vector along for this axis. So this axis A has a unit vector UA, and it has three components UAX, UAY, and UAZ. For example, if this axis A is z-axis, then the unit vector for z-axis is k, and these three numbers will be 0, 0, 1. No x, no y, only k. But if this axis can be any arbitrary axis, then it can have three components: UAX, UAY, and UAZ. So in this equation, UA represents the unit vector along the axis A. R represents the position vector from any point along that axis onto any point A along the line of action of force. So this R, we have very much freedom to select R. We can actually select this as R and we'll still get the same answer, as long as the tail of the R is on axis of rotation and head of the R is on force vector.